This is the continuation of the the fundamental principles of mathematical operations. I was saying that in division, we call it a form of multiplication because it deals with a whole number and a fraction. A whole number and a fraction. So this is the same thing as 6 over 2 is the same thing as 6 times half, or you say half in 6 places. And this is equal to half plus half plus half plus half plus half plus half. Half and half will give you 1, another pair 1, another pair 1. Get them together, you get your 3. And that is that thing we normally do. 2 cancels itself 1, 2 cancels this 3, 3 times 1, 3. So, if I have succeeded in telling you, well, just trivially telling you that addition, subtraction, multiplication, and division all are performing one operation, addition, all are addition operations in these guys, directly or indirectly. I don't think I would be lying. So I think you agree with me now that when you do those things, you are doing addition. So quickly, let's leave that place, and then I will take you through what we call um, the rules of addition and subtraction of signs. When you add or subtract two numbers, they have signs. There are two signs we know in mathematics: the positive sign and the negative sign. The positive is the plus and the negative is the minus. Any positive number is always at the right hand side of 0 on a number line. All numbers going towards the right are positive, and all numbers coming towards the left are negative. If the number line were to be a ladder with 0 at the center, all numbers going down are negative and all numbers going up are positive. So that's another way you look at it. So if you are to put two numbers together, adding two numbers together. So I won't be using subtraction more. I'll be using subtraction less often now. So if you are to add two numbers together, irrespective of their signs, there are rules you will have to look at. The first one is when they have the same sign. When they have the same sign, either negative and negative, or positive and positive. If they have the same sign, the only thing you need to do is put those numbers together. Put those numbers together and leave your answer with that sign. Leave the sum with that sign. So it's simple actually. We already know that 5 plus 6 is 11. What we have done is this: 5 is positive, 6 is positive. We put them together, 11, and the answer is so positive. Now, I will quickly tell you that when a number appears to have no sign, then it is positive, because the positive sign there is invisible. That's how we say it. It's invisible. But if it is not positive, then you must see a negative sign there, since that's the only other sign that we could have. So if we also have something like minus 7, if we're adding minus 7 to minus 11, this and this, some people get confused when they see things like this. No. Since they have the same sign, put them together. When you put them together, you get 18, and the sign they have is negative. So it's as simple as that. If they have the same sign, put them together and give them that sign. The second one is if they have different signs. If they have different signs, I try to let my students know this so that they could apply it all the time. Either one is positive and the other is negative, or the first is negative and the other is positive. It doesn't matter the order. What matters is you are dealing with numbers with different signs and you're putting them together. What it means is this: you'll be looking for the net net value. That's what you um you call it, if you can. Now, if they have different signs, what to do is, I will use subtraction here. You say subtract them, especially if they are just two numbers, and then give the answer, leave the answer, leave the difference with the sign of the larger number. The larger number there is technical. I wouldn't want to go into it, but for now, I wanted to stick with giving them the sign of the larger number. For example, we have things like minus 7 plus 11. This is negative, this is positive, so they have different signs. What you do is subtract. When you subtract 7 and 11, you have 4. And the sign the 4 we have will depend on the larger number. The larger number here is 11. So since 11 is positive, then the answer will be positive. Another example, you have things like 11 minus 23. 11 and 23 have different signs. This is positive, this is negative. Since they have different signs, you subtract. When you subtract, you have 12. Then the sign of the larger number is 23. Each sign is negative. That is how you do things like this. For the last example, I will get numbers of different, okay, let me call it number 3. If there are several numbers or terms with different signs, what you do is group them according to which signs they have. All the ones that are positive, bring them together. All the ones that are negative, bring them together. Then apply the first rule. Since they have the same sign, add them together, give them that sign. Then the second rule, you will see that they have different signs now. Subtract them and give the answer the sign of the number. For example, minus 3 plus 5, minus 2 plus 6, minus 10 plus 9, and minus 13. We want to solve this. This is nothing but get all the ones that are negative together. This has a negative sign. This has a negative sign. 10 has a negative sign, and 13 has a negative sign. And get all those with positive signs: 5, 6, and 9. Okay, 5, 6, and 9. Put these ones together and give them a negative sign. This is 5, 15, 28. So it's minus 28, negative 28. And this one here, you have 20, positive 20. We apply the second one now. It will leave us with 8 as the net. Because the higher number is negative, that's why you have minus 8, negative 8. So I believe this will go a long way to helping you to solve this kind of problems. Then we also come to multiplication and division of numbers with signs. There is nothing else I will say here, but that in multiplication and division, since division is just a type of multiplication, the same rule applies. That when numbers of the same sign multiply each other, the answer must be positive. When numbers of the same sign multiply or divide each other, the answer must be positive. When numbers of the same sign multiply or divide each other, the answer must be positive. I need to know that so that we can move on. So the answer must be positive. So it doesn't matter what the number is. Once they have the same sign and they are multiplying each other or dividing each other, you have a negative answer. Okay. For example, minus 2 times minus 10. First of all, you multiply the signs. Minus and minus. Minus times minus will give you plus. Then 2 times 10 is 20. It doesn't matter the size of the number, but the sign, the conversion of the sign. Then I'll give something like this. Minus 3 times 5. Okay, times minus 5. When you see a bracket, to open up that bracket, we use multiplication. Okay? So that to open up this bracket now, it means minus 3 times minus 5. Minus times minus plus, then 3 times 5, 15. So things like this, you'll be seeing them in various ways while you solve problems in mathematics. The second set of rules I will tell you is this. When different signs multiply each other, the result is always a negative. The result is always negative. When they multiply or divide each other, the result is always a negative here. So it doesn't matter the magnitude of the number, just the sign is what matters. Minus 3 times minus 12 plus 12 actually, sorry. This is a negative and positive. If they are multiplying, you have a negative 36. Understand it that way. Here, minus 40 divided by 5. Because 5 is positive, negative upon positive will give you negative, and this will give you 8, minus 8. So there isn't much we will do here. I think we have taken care of that the fundamental principles of mathematical operations, the addition, subtraction of signs, multiplication, division of signs. So we'll quickly go to algebraic expressions. In algebraic expressions, we have keywords we have to know. Algebraic expressions. Algebra, that's the keyword. Algebra deals with letters and numbers. Letters and numbers. Another one is like terms. Like terms. Like terms are those terms which have exactly the same letters. When they have exactly the same letters, they are like terms. For example, you have 3xy, you have 5x squared, you have minus 4x, you have 3y, you have 9xy, you have 15x squared, you have 25y minus 25y, etc. From this set of terms, the like terms there are the ones that have exactly the same letters, like this and this have exactly the same letters. So 3xy and 9xy are like terms. Another one, this and this, 5x squared and 15x squared are like terms. Another one, we have okay, 3y and minus 25y are also like terms. So you know what like terms are? Why are we bringing like terms? Because like terms, it is only like terms that can be added or subtracted. Only like terms can be added or subtracted. No this and no peace. Okay, so that is it is the main thing we'll be dealing with in algebra. That is what algebra is about. Algebra is about mathematics of letters and numbers, how they combine, and then addition and subtraction of those terms. So let's look at simple examples of how we apply this. So an algebraic expression is an expression which consists of letters and numbers with different operations. Letters and numbers with different operations. For example, I have how many x? X is here. So if I have a tray having this and this, I will simply say in that tray there are 2x. It's easier understood this way. What did I do? I just did this is 1x, just 1x, and this is another 1x. I just did 1x plus 1x. I got the coefficients. I'll tell you about coefficients. I got 2x. So here, coefficient is any number which is attached to a variable. A variable is a letter or a symbol in mathematics. So which is attached to a variable by multiplication. Okay, or in other words, even division. So here I simply added the coefficients, not the x. Like I have an orange and an orange. If I have one orange here, one orange here, I put them together, it's simply 2 oranges. So it is the coefficients that I am adding, not the letters. So remember, it's a coefficient that we add or subtract when we do those things, not the letters. So in this tray, we have seen that we have 2x there. That's how you can understand it very well. So if I have a problem like this, and this 2x means, this 2x means 2 times x. Like you're saying 2 oranges, 2 times x, or in other words, x in 2 places, just like we have seen. So if we have 3y, we are just talking about y in 3 places. Y plus y plus y, and we're adding their coefficients 1y, 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 1 plus 1 plus 1, 3. Is simply, these are simply ways you can understand these things. So x and y are unknowns, what you call unknowns, or variables. They help us, they are placeholders. They help us to give a name to something that is nameless. And when we find them, we are finding what was never known before. So let's take an example of how we can apply this in calculation. For example, if we are told to put stuff like this together, 2x minus 5y